Welcome to the Explainer. Today, we're tearing down a huge misconception about how computers process math. You probably think of your machine as this flawless, perfectly rational engine of pure logic, right? Well, we're going to pull back the curtain on the actual physical limitations affecting decentralized networks like the EVM, and we'll uncover a massive hidden barrier known as the trig wall. Okay, let's kick things off with a statistic that honestly completely blew my mind. 80 to 90%. That is the percentage of modern AI compute cycles that are, well, not exact calculations at all. They're fundamentally just hardware-level approximations. See, when massive models are doing their heavy lifting, the physical engine driving them isn't crunching absolute ground truth reality. No, it's essentially just making really, really highly educated guesses so it can process continuous data at blistering speeds. So, this brings up a fascinating and kind of terrifying technical mystery. What if your computer is fundamentally just guessing the math? Like, how do perfectly logical systems, and we're talking multi-billion-dollar decentralized networks here, how do they survive when their entire foundation is built on estimations rather than flawless, exact calculations? Let's figure it out together.
Section 1. The illusion of perfect computing.
The root of this whole illusion is something called floating point non-associativity. It sounds super academic, but it's really just a physical hardware limitation. Because computers don't have infinite memory, they constantly have to chop off microscopic decimals, like, say, just dropping the 23rd bit entirely, just to squeeze continuous real numbers into fixed digital slots. Now, in isolation, dropping a tiny fraction seems completely harmless. I mean, who cares, right? But over billions of concurrent operations, those microscopic rounding errors massively compound. A tiny little hardware quirk suddenly transforms into a massive structural liability.
Section 2. Meet the FPU gambler.
To really grasp this, we need to look at two totally different ways microchips process reality. On the one side, we have the floating point unit, or what we can call the FPU gambler. This guy is wildly fast, highly probabilistic, and honestly, when it encounters complex math, it essentially just throws darts at a board. On the flip side, we have the arithmetic logic unit, the ALU surveyor. This one is slower, methodical, and 100% deterministic. It deals strictly in verifiable truth. But here is the wild part. Modern AI relies almost entirely on that frantic, guessing gambler. So how exactly is the gambler throwing these darts? Well, chip manufacturers like Intel or ARM literally burn their own proprietary, completely secret seed tables directly into the physical silicon to help the processor guess the math incredibly fast. And this brilliantly illustrates the absolute core of the problem. Because this underlying physical math is a corporate trade secret, getting exact one-to-one mathematical reproducibility across different machines is literally physically impossible. It creates this unpredictable, non-deterministic drift. Basically, you're sacrificing exact bitwise certainty just to go fast.
Section 3. The wood chipper effect. Relying on that FPU gambler triggers something researchers call the wood chipper effect. Let's walk through how this works. Step 1. A system ingests exact, highly specific source data. Think copyrighted books or perfectly balanced financial ledgers. Step 2. The FPU violently approximates the math using those secret silicon tables we just talked about. And step 3, because that math was fundamentally just a lossy guess, the original mathematical identity, the exact chain of title of that data is irreversibly destroyed. It's just gone.
I absolutely love this visceral metaphor from the source material because it just hits the nail on the head. It's like a giant blender. Once your data passes through these hardware approximations, you can never, ever perfectly reverse engineer that digital smoothie back into its original components. The provenance is wiped out right there at the silicon level. Which means if you need to actually track digital truth, using complex math becomes incredibly risky.
Section 4. Hitting the trig wall.
And that brings us to the EVM, the Ethereum virtual machine, and this formidable computational barrier known as the trig wall. See, the EVM acts as a global, replicated state machine. For consensus to actually work, every single node on the network must compute the exact same result, down to the absolute last decimal. Because of this, the EVM absolutely cannot natively process floating point math or continuous trigonometry. Think about it. If independent nodes relied on the FPU gambler and all guessed slightly different decimal answers, consensus would instantly break. The chain would fork, and literally billions of dollars could be compromised in a split second. So what happens when developers try to bypass this trig wall? Well, they often try forcing a blockchain to emulate floating point math in software, using things like Cordic algorithms or Taylor series.
But the gas costs, they become an absolute financial nightmare. A simple addition that costs 1 to 2 gas natively balloons up to around 25 gas when it's emulated. Complex math becomes astronomically expensive because you are forcing a rigid, deterministic system to perform hundreds of operations just to fake a single floating point decimal. Section 5. The ALU surveyor solution. The solution here is to completely abandon the gambler and fully embrace the exact ALU surveyor. The arithmetic logic unit operates on a perfect, relentless metronome. It flat out refuses to guess. In its world, 1 plus 1 is exactly 2. Every single time on every single machine on Earth. No exceptions. It provides the absolute verifiable truth that these high-stakes systems desperately need. To actually achieve this on-chain, Web3 developers executed a brilliant technical heist to basically tunnel right under the trig wall. It's a 3-step process. Step 1, they completely abandoned messy continuous Euclidean curves. Step 2, they resurrected ancient math, specifically Pell's equation, to map circular geometry using strict, exact integer sequences. And step 3, they execute this division-free algebraic math solely on the ALU. No rounding, no decimals, no FPU gambler required, just pure, precise integer geometry. It is really elegant. And the results of ditching the gambler for the surveyor? Absolutely staggering. By tunneling under the trig wall with integer math, developers achieved a 74 times reduction in energy consumption. 74 times. We're talking about dropping the cost of these complex coordinate rotations down to an astonishing 0.005 picojoules per operation. You get flawless, deterministic exactness, and it is exponentially cheaper. What this ultimately means for the future of Web3 is profound. By shifting our math away from lossy curves and mapping liquidity to exact integer identities, we stop the wood chipper effect dead in its tracks. Relying solely on the ALU surveyor guarantees that your data retains its exact provenance. You get a verifiable, globally accountable digital receipt that is mathematically precise and structurally secure against all the chaos of non-deterministic drift. Which leaves us with this final provocative thought to ponder. As our digital systems become more advanced and the stakes get higher and higher, the foundational math we rely on matters more than ever. So, when your digital truth, your assets, or your provenance are on the line, will you blindly trust the chaotic guessing of the FPU gambler, or will you demand the absolute, undeniable certainty of the ALU surveyor? The choice determines the reality we build. Thanks for joining me for this explainer, and keep learning.